Good afternoon, everybody. You're very welcome to CitA Tech Live 2020 Virtual Summit, Day 3. My name is Alan Hoare. I am based in TU Dublin in our School of Surveying and Construction Management. And I'm also one of the founding members of the Construction IT Alliance almost 20 years ago. So this is our event today. It's about changing the way we work. This week, we will be hearing from 20 experts from across the globe who are already disrupting, introducing innovative approaches to how we're going to be working in the future. We had an interesting couple of days, Monday, Tuesday this week, where we heard about sustainability. We heard about the future of places, business opportunities that are presented by this pandemic, and also the culture shock that companies are experiencing as they grapple with particularly digital technologies. On day 2, yesterday, we heard about the potential for machine learning to augment and support design processes from Professor Philip Bernstein in Yale University. We also heard from Alice Young about the tech trends in construction and where there is still opportunity for companies to develop new technologies, such as in developing new materials, and also technologies to support industrialization, modularization. We also heard about how it's so important for clients now to pick the correct procurement methods when deciding on digital approaches to construction. So today, Shannon, you might share the program with us this afternoon. Just getting up there. Thank you, Shannon. If you just enlarge that for me, please. So I'd like to welcome all our attendees today, but also our speakers. Today we're going to be talking about how digital twins will revolutionize the construction industry. So our speakers today are Bruce Mace, UCSF Health Executive Director, Facilities and Support Services; Simon Evans, Digital Energy Leader in ARUP; Hadeel, Saadoon, BIM Manager, Coventry University; Mike Stenson, Global Head of Innovation, Kingspan; and Anand Mashari, CEO and Founder of Invacari. You're all very welcome this afternoon. Thank you for joining us. So I mentioned over the last few days that even before the onset of COVID-19, the sector was experiencing unprecedented rates of disruption. And indeed, many companies are accelerating their adoption of technology, in some cases from 6 years to 6 months.
All right, thank you. Can you see my screen there?
Yes, we're good to go.
All right. So I'm going to be speaking a little bit today from an owner's perspective with regard to the digital twin. I work at UCSF Health here in San Francisco, California, and we've been on a journey, if you will, with the digital twin for quite a while here. How do we use the digital twin? The vision becomes the road. What do we want to use the digital twin for? How are we going to get value from the digital twin, and what can it add to our world as an owner, and in my case, facilities and support services? That becomes the sort of the defining moment here for us. So my suggestion is that we define the digital twin for your potential, and in our case, for our facility-centric potential. Buzzwords that drive industries: AI, digital twin, IoT. We're looking to use those things for solutions that generate real change. It's important to define target goals and paths forward that are going to yield solutions to solve real-world problems. And these days we have a load of real-world problems that we need to be addressing. Early on, it became obvious to us, our team here, that the options were myriad The horizon was blurry, and there were technologies that were developing on a daily basis that didn't exist 5 years ago. And we sort of adopted the keep the threshold low enough mentality so that you can get over the threshold and move on to next steps. I'm suggesting that we don't dance with the entire twin, that instead we build a foundation and we leave doors open that are going to allow us to remain agile, to change with technologies as they come on to the horizon, and that we not exclude opportunities. So let's take a look at what a twin may really look like. Once again, UCSF Health. Here we're going to start off with just a very simple discussion of defining the twin through a building information modeling execution plan. And we have defined our BIM execution plan here at UCSF Health. And project to project, iteratively, we are updating, we are adding to, we are taking suggestion, and we are working with our contractors, our architects, our trades, and we're doing a project by project implementation of the guidelines. It's collaborative authoring. We are working with, we are not demanding that we have a single path forward, and in this way, I think we really benefit from the knowledge that the industry has and that our partners bring to the table to our BIM execution plan template. It's a live document. We update it over the course of a project and we keep at it, but it's the definition. It's the actual definition of what our twin is to look like. We have a sharing platform, in our case, Autodesk BIM 360. And we have modeling standards, model coordination, BIM data sources, and we allow exceptions. We have an ongoing conversation with everyone involved with projects. And I thank our senior leadership for allowing facilities and support services to be involved early on and very, very involved in the process. We don't prescriptively mandate designing construction practices per se, but we do sit on top of the output deliverables. One of the keys to the whole process for us is our BIM execution plan. We need to conform the twin. We need to make the twin what we need it to be to perform the work that we have here in facilities. You'll look down at the bottom here, and we have turned it into a very active tool. This is shared all around, and it is utilized very heavily by all of our trade partners. The BIM data requirements, we actually need to specify the twin that we're looking for. And in our case, we're defining roughly 5 to 10% of the assets and data that are included in the models. We have approximately 250 equipment types and families. It boils down to the simple information, and some of it more complex, obviously, that we need to operate. And early on, we defined patient safety, regulatory agency, preventative maintenance, predictive maintenance. We defined our world, what's important to us to do a good job, and we heavily defined that amount of data. A lot of it we let float to constructability so we don't add overall cost to projects. Reference, assessment, and review. We need to validate the twin to make sure that our specification and that our data requirements are being met in the model and in the database itself. We have created an assistant for Revit that sits on the model. And it calls the model for our BIM data requirements. It does ad hoc reviews and assessments that we can share with our partners. And we also then use it to meet milestones that are tied to contract. It's a very useful tool, bilateral. It goes back and forth with our teams and with the outside teams participating in the project. All of that information then is shared, and it allows us to move forward and with an agreed upon model as we move through the project delivery schedule. And what that boils down to is the actual model. We sit on top of it. We provide the conformance requirements. We provide these tools through contract to our trade partners. So in essence, we have created with a small group of a couple programmers and a solutions architect and our architecture partners here at UCSF, the tools that are required to help people move through the milestones and create the QA, QC deliverables that we mandate for operations. And in the past, it could take 5 to 11 months to load all the data from a, let's call it a 200,000 square foot hospital into Maximo, which is our CMMS. And in our last full iteration of utilizing the twin and QA, QC, and all of the automated tools for the process, at turnover, it was actually about a 5-hour process instead of 5 to 11 month process to load up our CMMS. What does that do for us? Once again, talking about a digital twin from a facility-centric perspective, we need to have a return on investment, and we need to be able to share with our leadership the hows and the whys and the return on what we're doing. So a couple big areas, big buckets of what the digital twin is doing for us here in facilities. Emergency response, it greatly shortens the time frame for emergency responses. We did a case study of a couple major floods that we had at 2 different hospitals, and we compared one which had happened in our older hospital up here at Parnassus, where I'm sitting today, and 15 stories. Our plan room is down in the basement. The leak was up on the 15th floor. And what does it take to actually access plans to get at the information that was required to resolve that flood and the time it took to contain and remediate? Versus down at Mission Bay, new hospital, we had a digital twin. We ran for the nearest computer and we got into the model and we were able to identify, isolate, and remediate very quickly. Well, there was a huge cost savings in there. Productivity, what is it for our boots on the ground? The ladies and gentlemen that are out on the floor every day, 24/7. Being able to look at models on handhelds, telephone devices, cell devices, iPads, very, very beneficial, and probably one of the most beneficial aspects of a digital twin that we discuss. But on a reel-to-reel basis, it's having 2D and 3D, and 2D being the slice of the 3-dimensional twin available to everyone that's working there in the field. Closeout management. This one is probably most exciting to myself, moving from a career in architecture and planning, design, project delivery, and coming over to facilities operations, the dark side, 15 years ago here at UCSF. How do we provide the information to move from a project delivery into operations? If we're spending 20% of our dollar in design and construction to get a building to the finish line, and then we spend 80% of our dollar over the next 50 years trying to efficiently operate it, and that ties into sustainability, into resiliency, and utilities. How do we become more efficient and take care of our environment? I would propose, and I think this area of laying down the silos and taking down the fence that used to be delivery is probably just about the most important thing to the digital twin that we're realizing benefit right now. Accuracy, without BIM specification, with BIM specification, this is the definition of the twin. How do you want the twin to behave? What do you want the twin to look like? And what sort of work is the twin being designed and specified to output for your operations? Once again, I'm facility centric in this case, but our model, our living as operated model, which is our twin, we are now tuning up for the next steps, which is to involve colleagues here at the hospital. And in this case, it's going to be pharmacy and IT, and two groups that could really benefit from sitting on top of the model and making sure that we're providing data that they need for their day-to-day operations. Lessons learned, our project teams that we need to coordinate with the construction schedule. On the data dictionary, moving in movable assets into our twin so we can tie into ClinTech, so we can tie into pharmacy. We start expanding the definition of our digital twin to provide the best value for UCSF Health as an enterprise versus a strictly facility-centric perspective. Early communication with the general contractor, sitting down at a table with trades, with the construction partners, with our architects, to really share what it is we're all trying to do is absolutely key and very, very valuable. And then the BIM guide, BIM guidelines, execution plan, all of the alignment of what we want to do with the twin becomes very, very important. In operations, just a few examples here of how does this digital twin work for us in operations. If this is our digital twin here, our living as operated model, we have project teams that are from the project providing information that we are defining, specifying, and bringing to the living as operated digital twin model. And then there's the data shuttle that takes place into our CMMS, our computerized maintenance management system. And this is where we live. And in our case, it's Maximo. And we sort of joke about it, but Maximo here is our religion, and everything flows out of Maximo. And the integration of the model within Maximo and being able to look at our digital twin in 3 dimensions within Maximo is critical. And there's also a body of work here, very important, with our ladies and gentlemen out in the field that do the work. And that is sort of robusting, as we call it, of the model. How do we add data from the field as we go along? How do we commission our models? And how do we validate accuracy in our models as we're delivering projects? Big example for us when we move into a new building in this use of the digital twin is the electronification, as we call it, the digitalized inspection forms. Electrical safety check being the most basic. 6 steps to bring any asset into our world. For regulatory purposes, we have to go through an electrical safety check. That is the most basic PM, if you will, the initiation, or what we're calling a birth certificate for an asset. And we're actually providing birth certificates for assets in the building before the building comes out of the ground, because we have the model and we are robusting it with the information we need. On the other end of the scale, emergency generator testing meter forms. These are upwards of 70 to 80 steps to do our mandated testing of our generators, which become incredibly critical when they're needed. And this process, because we're web-based and our regulatory information is web-based as well for when inspections take place and when our accreditation agencies get here to the hospital, we now have Maximo, and we took this one as an example in web-based form. As they are checking off and doing the PM and certifying completion, that moves forward into the regulatory world. And that saves huge amounts of time, and we can be sitting at a table with the regulatory folks being inspected, and data can be changing in our forward-facing model as we go through the inspection. When we walk through objectives, we want to validate the equipment's physical position against the BIM floor plans. This is ongoing and takes place during the construction project. So by the time that building is stood up and getting close to turnover, our engineers, our field folks are all 100% familiar with every inch of the building. And we joke about it, but we say we could sit down in lounge chairs on day one and be ready to go because we understand the building so well. UScan, unique scan number tied into the system so that we can build into other databases. We can touch other departments just as a manner of communication. And then there's the asset coordinates and the BIM floor plans. Where are things? How are they tied to the geospatial? And that ties into our space management, into our work order, and the rest of it. The digital twin. Pharmacies in the past, on our most recent project, we had 14 pieces of refrigerator equipment in one room. We specified location. We needed to know where they were because that would identify which asset was tied to which history, which work order history, and it becomes incredibly valuable. We can generate Maximo work orders from the digital twin. We can verify the equipment, and even an individual piece of identical 14 pieces of equipment in one room, which is which history, and generating asset-specific work orders. We inspect, we perform the electrical safety check, and then we verify against our database. So people ask about 2D. Most of our buildings are older, and we get 2D out of those buildings. We are tying 2D to the models, and in our three-dimensional digital twins, two-dimensional availability on handheld device is merely a slice of the digital twin based on our definitions and specifications. And those assets are then sitting inside of Maximo, and we have the entire database, the model information, the metadata stored in the objects that we specify from the actual project delivery. So wrapping it up, we are on Maximo version 7.6. We are integrating BIM data to facilities operations, and we're getting new workflows out of it. We're taking a huge digital step forward, and I think it's important for our future. Just want to thank everyone here who took the time out, and we're open for questions. And Alan, I'll let you take it from here.
Thanks very much, Bruce. Really interesting. It's great to see the progression of your work in the Bay Area. I've just got one quick question. It might be a very straight answer. How early is your team involved in the design process?
Yeah, good question. So we've got two very large projects starting right now, one of which is called New Hospital at Parnassus Heights. It's going to be delivered in 2029. It is a 400-bed, 19-story hospital tower right outside my office here. And we are involved from the programming stage, and we probably have about 7 or 8 hours worth of meetings every week with partners like ARUP, and others, and we are involved at that stage all the way through project. So once again, the important part is that fence comes down. There isn't a delivery fence. It's more of a continuum.
So that leads into one of the comments we have from Ralph Montague, whether Ralph wants to come in and ask the question, but he's talking about the problem of rework. It was definitely something that was mentioned yesterday by Daniel Doherty. You know, a contractor receiving the model and it wasn't buildable. And this was the big problem. And then potentially if the model went on then to the client, it wasn't consumable by the FM team. So Ralph, do you want to elaborate on that question?
Yeah, and that seems to be a recurring problem on projects, that there's rework between the phases. And I was just wondering, Bruce, if there's a lot of rework of the models between construction and FM, or or are the quality of the models you're receiving good enough to be consumed by FM?
Well, I think you said it right there, Ralph. Are the models you are receiving of good enough quality? That is the conversation. And the tools that we have built for QA/QC guarantee that quality of model. And as things are being changed or reworked during the construction and delivery phase, absolutely, those updates are made in models so that we settle on our deliverable, which is the living as operated model at the end.
And
if
then,
you don't do that, you're dead in the water for the rest of the life. Yeah.
And then turning it just to my second question in the chat was, now that you've gone through all the trouble of getting a good quality model, when you start a new project, do you give the design team good quality BIM objects as a starting point, or do you get them to start from scratch again?
No, the whole idea of that living as operated, we are starting our, if you will, a corral of operations, which is our existing buildings, and then any rework or any change, those models then are provided to our partners if there's rework to be made. And then, of course, you get into what about smaller projects, smaller architects, and that's where our own change management, our own internal architecture comes into play.
Thanks, Ralph. We have a couple of comments there on Maximo. Sean Dennison there. Is classification enough for interoperability between Revit and Maximo, or do you need guides? Now, that might be a technical reference. Is it, Sean?
No, I suppose it's a follow-on from what Ralph was saying. That
just speak up loud. Can you just elevate your voice there a bit? Yeah.
Sorry, yeah, I'll try.
Yeah.
Just following on from what Ralph was saying, one of the reasons I think, Bruce, for the fence is that you need to re-identify assets, locations, and so on many projects when you move from or when you move through the handover process. So I'm just wondering, is classification enough to do that, or I noticed you're using some kind of scanning for assets and locations, I assume. Presumably that is some kind of unique identification.
Absolutely, it goes beyond classification. And Sean, if you reach out offline, we can have a good conversation about that. But the construction, building of tools for especially movable assets, how do you RFID, how do you track your space, changes to space, movable equipment, what assets are owned versus, anyway, a whole nother workshop there.
Okay,
Sure,
thank
yeah,
you.
Thanks.
So we're just getting a little bit of feedback from someone's microphone there. People could just switch off their microphones if they're not speaking. And we've other comments, but we'll come back to those, Bruce. Thank you very much. Very insightful. I'm sure there'll be lots of questions for you as we come towards the end of. Yes.
Very good. Thank you, Alan. No, much appreciated. So I'd like to start my presentation by really sharing this image on a quote which many of you might be familiar with from Henry Ford, which says, if I'd asked people what they would have wanted, they would have said faster horses. So the reason for starting with this is I think this point really resonates when it comes to digital twins, because it often talks about the point of education and the fact that it's very hard for many to conceptualize what you can achieve with a twin unless you go about showing them rather than necessarily telling them. So on that basis, I think it's very much in the gift of us as people in industry to try and shape how we communicate digital twins in a more transparent and more pragmatic way, which leads me on to what I'm going to talk about today. A very long title of how can you drive tangible benefits through adopting a full life cycle digital twin approach, or probably more concisely, are you tired of all the unicorns surrounding digital twins? So as Alan very kindly introduced myself there, I'm Simon Everson at ARUP. I lead digital across our energy sectors within ARUP, but I also work very closely with the National Digital Twin Programme that's led by the Centre for Digital World Britain. So it's hard not for us all to get excited by digital twins when you hear statistics like this, that the global digital twin market was valued somewhere in the order of 3.1 billion this year, that's including the COVID impact, and is expected to reach somewhere in the order of 50 billion by 2026. Now, however you order value and consider how that slice of the pie is going to be divided up, there's still a significant increase in this market segment, if you will, and therefore plenty for all of us to use and play with. or other statistics such as this from a Gartner report now a couple of years ago, where half of all large companies will be using one in some form by 2021, resulting in a 10% improvement in effectiveness. Again, what a digital twin is here is not really concisely shown, but it shows that we're seeing a lot of people talk about how there are going to be benefits coming from it. But first, before I get into talking about digital twins, let me first introduce ARUP and who we are. So ARUP, many of you may know, are a large multidisciplinary engineering consultancy firm. We have about 14,000 employees working across 33 countries, and we cover pretty much every single sector, from cities to property to energy and to transport. So we work across many markets, and of course, because of that, we're an engineering consultancy, not a technology company, but we recognize the trend of digital twin is prevalent in all of the built environment, and therefore, within what we're looking at, it's fundamental to how we respond and keep ourselves fit for the future, if you will. So I want to first cap on what a digital twin is, just to really make sure we're all on the same page of the definition. So if we consider what a digital twin is in its simplest form, and as Alan introduced earlier, we've got a physical asset, and here I'm using a representation of a train, but it could be anything, it could be a building, it could be a bridge, and then we have some type of digital version of that asset. So this digital version can be in a level of detail proportionate to what you're trying to achieve from it, by which I mean it could be a fully detailed 3D model with every nut and bolt shown, or it could just be a simple sketch, a 2D map or system. Again, it depends on what you're trying to achieve. Now, between the physical and the digital, or the real and the digital, you have data that flows. Now, this data flows at the right time, not real time, and that's important because nothing really ever needs to be real time. It's about having the right time of data flow that's pertinent to what you're trying to achieve. Then within this digital environment, you can use that data, you can analyze it, you can assess it, and derive insights from it. And using those insights, you can make decisions. Those decisions then allow you to make interventions back into the physical, where outcomes are delivered. Now, a couple of key things here. Many people think that the data flow from the physical to the digital has to be using sensors, so IoT, for example, but that's not strictly true. It's any type of workflow that takes physical data about the physical environment or the physical asset into digital form. So it could be someone typing information in a spreadsheet, for example. But the key that makes a twin different from a 3D model or other representation is this feedback loop, the interventions that you have back into the physical asset from the digital. Now, this feedback from digital to physical, physical to digital, and back again is the kind of the concept of a digital twin. Now, this is quite important because we've had this naturally for a number of years, but why we're seeing it more prevalent now is because the emergence of things like storage, compute, and connectivity, which bring these two worlds together. Now, on that particularly, digital twins are not new at all. One of the first examples of digital twins being used was actually the Apollo 13 missions, where at the time they called it digital mirroring and allowed the astronauts to get home safe. But it shows this has been a long-term trend for the last at least 40 years or so, and we've seen aerospace and manufacturing having it for the last 20 years, and my background, which is in oil and gas, being for the last 5 or 6 years, before most recently in the built environment, who've picked it up in the last 18 months. Now, the next key thing that we often hear is people saying that digital twins are here to replace BIM. Again, that's fundamentally not true, because BIM, or as its concept, information management, is a core component that you need in order to enable the outcomes of a digital twin. Because without information management and data management, you can't do all these things people brag about, like predictive maintenance, reactive decision making, or AI or ML, for example. That's why in ARUP, and also aligned with what CDBB are looking at, we term it more appropriately as a digital twin approach. Approach here being the key word, because it really talks about the fact that a digital twin is actually a methodology and a way of working, not a technology or product. By which I mean you can't just go buy a digital twin and solve your problems. It's actually about fundamentally changing the way you operate as a business and how you can converge physical and digital assets together. Which also, if we look at it, most people or most organizations, rightly or wrongly, when they hear about a digital twin, the focus is on that long-term aspiration, the unicorn of that fully autonomous asset that's self-controlling and do all these magical things. What we really should be focusing on is actually the incremental steps of benefit and value along the journey of achieving that digital twin. How can we introduce these use case driven approaches, answering particular questions along that journey, ultimately allowing us to get to that state at a future point in our organization's future and history. So there's a couple of documents that are quite influential in this context. Now, one I'd like to point you to particularly is a white paper released by the Institution of Engineering and Technology last year, which talks about digital twins for built environment and sets out in quite a readable way how digital twins work and how they interact and how you can go about procuring them in some capacity as well. But the interesting thing when we look at it is if we look at organizations and where they sit on a spectrum of data, and the spectrum running from visibility to interoperability, most organizations sit here on the spectrum, which is where they're trying to surface their data and make it more visible, understand what they have really within their own environment and their own ecosystem. And they're not really considering outside of that and how you could connect to other systems. But what we want to do is see how we can shift along that line to interoperability, whereby we're talking about how you can connect multiple systems together, ultimately creating an ecosystem of digital twins. And why is this important? Because that connection is ultimately where the magic will happen, rather than just looking at twins in isolation. Now, of course, we're not the first people to think of this, and within the UK sector particularly, there's a number of documents that have come out over the last couple of years which allude to this, such as the industrial strategy, transforming industry performance, and of course the final document here, which is the most important, data for public good. Now, looking at data for public good, which here in the UK came out a couple of years ago now, it set out a couple of objectives and outcomes, but the two I'm going to particularly talk about now is the creation of what they termed a national digital twin, which isn't a giant digital twin of the whole of the UK. It's more of a framework and language that allows multiple digital twins to talk to each other using an information management framework, the second point on the slide there. But I'll talk about a bit more of that now. Now, that national digital twin led to the establishment of a group called the Centre for Digital World Britain and a program within that called the National Digital Twin Program, which has been running now for the last 2 years and something I definitely recommend if you haven't come across it already to read more about. But if we look in detail about what that program is and we consider what Digital Build Britain is, Digital Build Britain will ultimately be where we have the whole built environment connected fully in all of its different layers to each other, allowing the seamless interchange and exchange of information between all of the assets it contains. But if we look actually at what was contained within the built environment and split it up between layers, you could say there is an economic infrastructure layer, a social infrastructure layer, and a green environment layer. Each of these layers might communicate within each other, but you don't necessarily have communication between those different layers, so data doesn't necessarily flow between them. Now, if we dive a layer deeper than that and unpack it by sector, you could say that you have an energy sector layer within the built environment where you might communicate through the grid to each other and you can balance it, but it's still quite contained within that sector. Similarly, you have transportation, water, social infrastructure, or residential, commercial infrastructure, industrial infrastructure, and finally the green environment. Again, all of these layers aren't necessarily communicating with each other. But if you could hypothetically allow or enable the connectivity of information between these different layers, it would enable you to take a systems-based view of the built environment, delivering outcomes in a systems of systems or a systems of services approach to both the society, the economy, and the environment. Now, what I've explained there really lends to creating this ecosystem of connected digital twins, whereby you can connect multiple twins to each other and the information flows between them. Now, to explain what that actually means in concept, and going back to my train example, if we have this ecosystem of connected digital twins, and we take this train as before, where we have data flowing from the physical to the digital, where insights and decisions are made, then interventions flow back into the physical again, this is great in the isolated case of a train. But if we could connect that train, for example, to the same digital twin of the signaling network and the points, for example, then you can create a digital twin or ecosystem, if you will, of that train system, that network altogether. Now let's connect the train network to the network for aeroplanes, so the aviation network and the road network, for example. Suddenly transportation now, the twins between all of them can share information equally and learn from each other and benefit each other. Now, if we take the transportation network and similarly connect that to energy and water, what does that mean again? Ultimately creating this digital twin of the entire built environment rather than just a digital twin of a train. Now, the interesting thing about this is if we look at it, it allows you to then interact each twin based on other twins. So, for example, going back to our train again, a train could have information fed to it from the road network, the rail network, the water network, whatever it might be, that would allow decisions to be made within that local environment. Now, the reason this is quite exciting is that many can draw parallels between this and the internet and how the internet functions. That, you know, a single computer is great, everyone loves that. Same with a single mobile phone. When you start connecting mobile phones together or connecting computers together into a network, you have that power, the aggregated effect, that's very hard to quantify, but we know has intrinsic benefit. Now, of course, I've grossly oversimplified there how the internet works and how GSM works, but the concept of what it means is why many are saying that the conversations happening around this National Digital Twin Programme, which is looking to understand how you connect these twins together, is as important to society and the economy as the conversations that were happening 30 years ago when Tim Berners-Lee and his team standardized the internet. Now, an example you might look at here that's quite relevant is if you were driving down the road in the future in your autonomous car, or I guess your autonomous car will be driving itself. It's electric, you're driving down the road, your car knows where it's going, it knows it has a certain amount of charge to get there, but also knows that in its current battery, it doesn't have enough charge to get to the end destination. Knowing that, your car can automatically communicate to the road network and say, hey, I need to fill up my battery, if you will. And that can communicate to the energy network, which in turn communicates to the nearest fueling station, and your car will automatically route to that station where the right amount of energy is automatically redirected, allowing you to fill up your car with the right amount of energy, if you will, so that you don't overcharge and have surplus, but also allowing you to get to your destination in the right amount of time. In doing so, further down the line, as you're about to set off, or further down the road, there's a storm ahead. And that, we think, from the meteorological network, is going to reduce the number of lanes that are being able to use on the motorway because of the rainflow could overflow the drains, and therefore all car network are evenly distributed between different routes to make sure there's not undue pressure on a new route. Now, why I say that is if you look at things like Google Maps at the moment, if there's traffic jam, they'll redirect you to another route, but it'll redirect all cars to that route, creating a new traffic jam over there instead. But if you can do it equally, and at the same time, let's say, reduce or remove ancillary flow from the water network to allow extra drainage from the stormwater and reduce the number of lanes to allow cars to travel through, you can get to your destination within the same time as before without impacting anything. Now, that connected system of systems thinking there is actually fundamentally impossible at the moment because of the way our infrastructure and systems are set up. And that's the aspiration of what the National Digital Twin Programme is trying to achieve. Now, a couple more things I'd like to share is if you look at that, it creates this connected ecosystem for the built environment. But the interesting part is when people talk about digital twins, we often focus about that 0.5% of new infrastructure and assets that are built every year, which in reality is pretty minor because 99.5% of assets are already in existence. And therefore, the size of the prize for digital twins is absolutely not the new build at all. It's actually the existing assets and how we can leverage that and what we can do in that space. Now, that's interesting because, of course, it's on us in industry to work out how we can respond to that and make sure that we're using the principles that are being put forward by programs like the National Digital Twin Programme to really leverage that. Now, that in particular, this program has released two influential documents. The first called the Gemini Principles. The second is one that came out fairly recently that explains about how we're going to do it. But the overarching mantra of all of this is a concept of collaborate on the rules and compete on the game, by which I mean no single organization is ever going to solve the challenge of what digital twins need to do or can do. So a software vendor, a consultant, a technology provider, they won't be the person that provides digital twins for the market. It's going to be collaboration across the market on the rules of how you go about standardizing, communicating, developing these type of solutions. And therefore, each organization can compete on the game, if you will, based on their own USPs and particular services. Now, the way this is going to be approached is in two forms. Typically, when you roll out programs like this, there's two approaches. The first could be a top-down authoritarian, where you just say, look, we're going to do this, and the market will either accept or deny it. Or the other will be bottom-up Darwinian, where you let the market fight it out. So the classic is the VHS versus Betamax, and hope that eventually someone will survive. Now, the landscape of digital twins, that's kind of a bit of a waste of time because you want to get to an end solution pretty fast. So therefore, the solution being taken by the Centre for Digital Britain is this twofold, where you've got both the information management framework, which is this resource, this language that allows twins to communicate on one side, which is centrally created and held in common, and on the other side you have the Digital Twin Hub, which is a community where individuals, asset owners, operators can get together and learn by doing and progress by sharing. Now, if you've not already come across this, I'd thoroughly recommend you check out the Digital Twin Hub. It's on screen now as a link, and it will take you to a forum where you can share lots of information and learn about all the different things happening across sector. Now, because I'm running out of time, I have got some cases I could share, but what I'll share instead is just this last slide of how can we move forward as a sector to deal with digital twins. Now, there's 6 things I think we should consider. The first is embrace the concept now. All new projects should consider a digital twin approach. If you're not considering it, all you're doing is creating a dumb asset for the future, and that's not going to be helpful for anybody. It's also very easy to value engineer out digital twins from the process, and therefore it's on us to make sure that they're not, and we do consider these concepts. Related to that, it's also a journey. Respect that it is an incremental journey of value. Nobody is going to invest multi-million-dollar in a digital twin for unproven technology with no return on investment. It's all about how can you do those thin slices, those early steps on proving value-returning developments to make sure that these are actually adding value and answering the questions you're asking. Also about collaborate. The fact is digital twin is actually cross-sector completely, and it's not something that any organization can do on their own. So let's get out of our silos and collaborate with each other. Lean on the regulation that's happening around this as well. The organizations such as the National Digital Twin Programme are really driving this forward and centrally regulating where possible, but on us as the industry to also try and align ourselves to that. And the final point is be sustainable. That adopting these concepts now will really help us move towards sustainable operations based on digital twins. So my penultimate slide as such, if you haven't come across this already, is their podcast has been recently established called the Digital Twin Fan Club. It's become fairly influential and actually fairly recently interviewed the creator or the founder, or you might say the father of digital twins, Dr. Michael Greaves, which is quite an interesting episode. So I'd encourage you, if you've not come across that podcast, to check it out on the right there. And that's all I'm going to share myself. I've got plenty more I can talk about. If you've got any questions, please ask in the chat window. If not, I'll hand back to you, Alan.
Wow. That was a fantastic presentation. And if any of you are in any doubt what a digital twin is, you now know. So thank you so much, Simon. That was really a fantastic presentation. You could keep talking, actually. I'd listen to you for another hour. Well done. So a number of questions. I suppose another observation there from Ralph. You spoke about getting out of silos. You spoke about collaboration. And I think Ralph might have an observation on that.
Well, it was a question really. There seem to be a lot of groups talking about this idea of an information management framework. For instance, the DigiPlace group in the EU, which is a project funded by the European Commission, and yourselves, obviously, in CDDB. And I was just wondering if there's communication happening between these groups, or are these efforts working in silos themselves?
There's absolutely communication, really open communication between these different groups, and also a few others that you've probably come across as well. The Digital Twin Consortium, based out of America, that's heavily software company provided and led, and also there's other agendas out of New Zealand and Australia doing similar. But yes, all of these teams actively collaborating with each other to make sure that the core principles are aligned and working with each other. For that very reason, because otherwise all we're going to see is a divergence and not collaborating on the rules, if you will.
Just a quick question, Simon, to you about your particular remit in ARUP is to do with energy. And we all know that digital twins is much more than just monitoring performances of buildings. Is that something you're contained within? Is that the brief, or is it much broader than that?
So my primary role, yes, within ARUP is I look after digital, and by that digital I mean emerging internet era technologies, not latest software or hardware, for example, within the energy sector. Yep, that's one of my hats, and those with.
So are you trying to ensure that the way we design buildings and the way that we design, that we simulate performance, that the building will actually behave as closely to what you intend in the design stage? Is that the idea?
That is one of the outcomes, absolutely. And actually, as you're asking that question, I'm going to quickly bring this on screen, which is an example of where we've done just that. So hopefully, if that doesn't come through in a second, it will. So this is an example of where we've done exactly that for a building in Hong Kong, where by creating a digital twin, if you will, of this building, it's the first AI-driven building in Hong Kong. You can check out the project on the bottom left there. We produced 30% savings of energy consumption based on normal conventional buildings by providing various analytical techniques, mapping out future and past weather patterns and occupational data and et cetera like that. So I could provide more on that, or the website will show, but exactly as you say, Alan, how can we really take this this approach of trying to create digital versions of a physical asset in a proportional level of detail to what you're trying to achieve? And that's important. You don't need to create a detailed 3D model. It could just be a 2D map or system. For example, air traffic control system, that's a digital twin of the sky. It's actually a system you'd see on a screen. And how can you leverage that in an appropriate way to answer an appropriate question? In the context of this, it was how can we reduce energy consumption of a building? And then we answer that question, then we can expand down and say, well, how can we now reduce water consumption? And that's the next use case, ultimately building out on the journey to that unicorn at the end, if you will.
Yeah, so both you and Bruce have the same message. You know, Bruce talked about not dancing with the entire twin, the agility, you know, keep the threshold low, don't over expect, you know, and it's really interesting. There's a common theme coming through there. And of course, you're talking about, you know, I suppose validating, and I know, Bruce, you mentioned validating a lot in your presentation, the idea of validating the benefit and the value as you go through the journey, through design, development, detail design, construction, FM. But going back to Bruce's point, you've got to have the FM people involved early on in the process. Absolutely. So that when the facility managers get this information, they can consume it. You know, that they can, it's practical and they're getting the right information. So
100%
any other questions maybe for Simon before we move on? Fantastic presentation. Lots of comments coming back about both the presentations there. Just the first two presentations are very, very good. Any comments there? See if we have any other.
Thank you. Thanks very much for introduction, Alan. Hello, everyone. My name is Hadeel Saadoon. I'm the BIM manager for Coventry University Estates. Today, I'm going to speak to you about our journey in digitizing Coventry University Estates. And when we started, first, we started by the aim of digitizing our information. And we didn't really call what we were doing a digital twin, because this term is very, very new. But as the information developed and as the industry developed and new concepts are emerging, we now started adopting those new concepts, and we are looking to develop a digital twin of Coventry University. So a little bit about us. We are I am based at the Coventry University City Campus. I'm saying a city campus is because our buildings are very integrated within the fabric of the city. So creating a digital twin of our campus will be very interesting because it will link to the city of Coventry itself. And when we started digitizing our building information, first we started at building level, and then we moved on to campus level. And I think the next stage in the future will be to also link with the city level. So this is a screenshot from Google. And this is the digital campus model that we have developed of our campus. So in the center, you will see a number of our buildings, and I've got more of the models that we've been developing. So what is our vision and the road to digitizing our estates? So first of all, we've started by looking at the existing information that we had and how we want to manage our information in a better way. We started by policies and standards. We followed the BIM standards that were available at the time, the British standards. Now that they have been elevated to international standards, we're still continuously developing them and following them. And we looked at retrospectively creating models of our existing buildings. So we had a lot of backlog of information that were out of date of our buildings, starting with building plans, and we need to update those. And we didn't just update the 2D plans, but we also created 3D BIM models of our existing buildings. It's we've got a large campus in Coventry, we've got a campus in London and another one in Scarborough, and we've got about 114 buildings in total, and we've managed to create more than 50 models of our buildings at the moment. We also understood that we need the right systems and we needed a platform to host all of our information. So we looked at procuring a common data environment, and we chose one that would, in the future, integrate with our existing state systems, so that's CAFM, BMS, etc. And realized that collaboration was essential to developing all of those aspects, and collaboration internally between our estate operation maintenance team, estate development team, and our digital services team, and also externally with our stakeholders, architects, contractors, suppliers, who work with us to continuously develop our campus and also build new buildings when we need new research facilities, student accommodation projects, etc. And the next steps, we always have in mind that we need to look at system integration, interoperability of information, because that will be the basis or the seed to develop a digital state or a digital twin of our campus. And of course, that will need continuous development. So we've looked at the Gemini principles of the digital twin, as my colleagues have mentioned. The CDBB are publishing a lot of excellent resources for us and the industry to look at. So the definition of the Gemini principles define the digital twin as a realistic representation of assets, processes, or systems in the built or national environment. And for those principles we're going to look at each one of those set of principles and how we want to look at them or follow them in our digital estate journey or plan. So first of all, obviously, the digital twin will need to have purpose for public good, creating value, and provide insight, especially for an organization like us. We are an asset owner and we are an operator of our buildings. So having a digital estate or twin will provide really good value to us. So we do want to add value statewide by having better information management. We have a lot of complex teams within the states. We've got environment team, development teams, access control, protection services, planning, health and safety, customer services, and of course, operation and maintenance. All of those teams rely on accurate building information to operate and manage our facilities and also provide better services to our customers, who are mainly the students and of course staff of Coventry University. So going digital was not easy. We started from having this physical archive. We actually had 4 rooms of archive that weren't really as tidy as the picture now. We've even tidied this up and now have just 1. And we had to do a full cleanup of those archive rooms and digitize everything. We've scanned the essential operation and maintenance manuals and building information that were necessary and got rid of everything that's not necessary. And we've moved on to develop digital versions of our asset information, and we moved on and got rid of the physical paper-based plans. And believe it or not, we did have some building plans in paper format yet, still at that point. And we've digitized them, creating digital versions of the plans in AutoCAD first, and then we moved on to Revit, created BIM models retrospectively, and we are developing a full digital archive of our building information and aim to host it on our common data environment. So the journey was not simple. We started by reviewing our existing state's infrastructure, our information requirements, and policies as information requirements. We've adopted BIM standards. We went out to survey our buildings to update the drawings, and we looked at our existing policies, health and safety, soft landings, a design guide, updated all of those policy documents, and then we looked at our systems and what was missing. We didn't have a common data environment, and we moved from CAD to BIM, and also we are continuously improving our asset management policies, building services. We look at systems integration, and all of this will help us to digitize our campus. So the process started with the start building drawings, then with data validation via surveys, drawings, modeling, space and data validation, and then having them all in a shareable platform through our systems. So we faced a lot of challenges because we've got complex systems, complex data, complex spaces, and we had to always keep in mind that we need to minimize risk, manage safety, and ensure that the data that we have, that we're updating, will help us in achieving cost savings and reducing energy, because when we have better data, we'll be able to plan and operate our buildings in a better way. So we have a very complex estate. We've got complex information. We've got a lot of projects, a lot of files, a lot of information and models and drawings, and we needed to ensure that all of those information are up to date and hosted in one open shareable location. We had a lot of backlog of data, so building drawings were not aligned to the actual as-built, so we had to do, that's where we had to start with surveying our buildings, creating those BIM models. We had to understand, ensure that the room numbers are in a unified format so that we can feed those room numbers as space data into all of our systems, including CAFM. We had to look at the consistency of the information, assets, and also that we request project information to have those consistent room numbering, and also to follow our policies to ensure that we receive accurate building information from projects and not just updating the existing building information that we have. Another big challenge was capturing the existing estates. So we do use point cloud surveys and scan to BIM services when we have refurbishment projects, but for the retrospective modeling of our existing buildings, we actually relied on basic laser scanning during surveys. So we realized we don't really have to have complex equipment or expensive ones to realize or achieve what we need. So we've done those surveys, we've done them with the laser scanning, created updated plans, and started creating BIM models of our buildings that then were linked to our campus model. So the other principle of the Gemini principles is trust. The information have to be secure, they have to be open, and they have to support us in quality management. So the main piece of asset information that we thought was crucial to the success of this project is space data. So we looked at space interoperability and realized that whenever a space changes, for example, when faculty decide to change maybe a small teaching room into an office space, that will affect a lot of other data sets at the university. So, and even changing the title on the door or the door number will have to will affect not just the digital asset that we hold, for example, in access control systems, but it will affect also the physical signage like the door number. It will affect our wayfinding signage. It will affect distribution board labeling. It will affect our plans, drawings, models, and everything. So we first had to identify a space change checklist to ensure that we manage the spaces correctly, and that whenever a space is changed, it is reported to us accurately, and we can ensure that all the affected areas are updated accordingly. We also have complex systems. So to look at systems interoperability, that was also and still is one of the essential aspects that we look at when we are digitizing our estates. And whenever something like a space or a building or a room number changes, it affects a lot of systems, and a lot of people don't realize that. It affects our ITS systems, our BMS systems, it affects risk management, access control, even catering, because they need to find the right meeting rooms and the right spaces. Affects timetabling and how our timetabling teams schedule the timetabling for the students to find their lecture halls. So all of this have to have accurate data and in the one unified format to allow interoperability between the systems. And we also, from the principles we spoke about quality, we wanted our digital processes to allow us to have control of the quality of the data we receive on-site and off-site. And this is an image in one of our newly built projects, which is the engineering and computing building. So having accurate BIM models from project perspective allowed us to validate the data on-site and not just in the office by looking at the BIM models and the clash detection reports. So having those digital workflows really supported us with on-site data validation and quality control. And we think Also, that's one of the essential principles of the Gemini principles. And we realized that all of this work of having those digital workflows is basically to support us as owners, operators, and support us as clients as well. And it will allow us to have better stakeholder engagement as well. So having accurate BIM models is also useful for visualization, which is one of the reasons why those models techniques were developed in the first place, to allow for stakeholder engagement, for us to work with our faculties to ensure that the space we are developing is meeting their requirements for teaching, learning, and will serve our students in the long term. So data governance and security, we realized that we had to have really good policies, and we had to ask for the right information at in our requirements. So we developed our exchange information requirements and our asset information requirements to ensure that we are requesting the right information on project level, to ensure we receive the right data that are useful and usable for operation and facilities management. So that brings me to the function principle of the Gemini principles. So the data must function effectively. So to have the right data, we looked at field-based integration, and we realized we need to have unified data sets. So starting by looking at our systems, we had to map our system requirements with the industry standards. Unfortunately, a lot of the CAD facilities management systems are still not yet developed enough to accept asset data coming from models in COBie format, for example. So we use a system called Planon, and we had to look at the existing fields that we've got in Planon, the system limitations, and highlight them correctly, and then map it with the COBie equivalent. And that will help our suppliers to understand exactly where to find the data that we need, so that they can give us the right data in the right format that we can then import into Planon and use for operation and maintenance. We are using this same unified dataset as well to capture the existing building assets. So it's not just for projects and for contracts and suppliers. We do use it to capture the existing building data as well. So our surveyors, our operation and maintenance managers, instead of using random spreadsheets or random formats, we have developed this unified dataset, and they are using the same one format to capture information that we then import to Planon, and we then assign the right planned preventive maintenance regimes to those datasets. We also ensure that the codes that are in our unified datasets are labeled correctly, because that will affect the labeling. So this code has to be unified and has to be the same in the label, in the system, and the same code that we provide or get from suppliers, and also that we stick on the physical asset as well. And that will give us the link from physical to digital. And we've developed an app to help us read this those codes from the physical assets, and it will bring up the screen of Planon to show the asset data that is held on the system. So one of the important things that we had to look at is having a maintainable asset list. So as a client, when we are in a project, we realize that we can't just ask for everything. We need only the assets that we actually maintain. So we only need meaningful information. So we've developed our maintainable asset list based on SFG20, which helps us to write maintenance codes that give us the right recommendation for maintaining those assets, and we follow those. So this helps us to also automate some of those classification processes, but unfortunately, we're still not just there just yet, because we still have to do manual check by our operation maintenance managers to ensure that what is recommended by SFG20 does not contradict with our warranty requirements. For example, SFG20 recommends that an asset is serviced every 6 months, but in the warranty, it says this asset actually has to be serviced every 3 months. So we have to update those service maintenance regimes on the system to ensure that we are following the warranty requirements to ensure it stays valid. So That's why we use SFG20 as a reference mainly. And it helps us to ensure that we're following industry standards, but at the same time, we do that internal management to ensure that it doesn't contradict with our warranty. So as you've seen, a lot of our processes are very spreadsheet heavy. So we're trying to make that smarter and work smarter. So we've developed those fields that we want into our common data environment system. And now we have a really good interface so that we can get those asset information from projects, from contractors and suppliers on the system itself. They can log into our system and fill those fields, and then this will update it on the system. We are still in the process of developing this, but the aim is also to link those fields to Planon and push the data directly. And also that will allow us to also get the information from models coming from Kobe that are hosted onto the common data environment, also in the same format, and push it to Planon from the system itself. And that is our first step of data integration that we are trying to work on to develop. So this is our digital twin vision. We aim to host all of those information on one system that then connects to our existing systems, so that when you look at our digital campus model, you can click on a building and then you can see the architectural, structural, and MEP model, and you can click on an asset and you can view all the metadata fields that are related to that asset, and those metadata or asset information are compatible with our CAFM system. And not just assets and information and metadata, but also documents. We want to host them in the same location, so that when you click on the documents related to that asset, you can view your O&M manual, and this will help you to and help us to have better information suitable for operation and maintenance. So that is our vision for Digital Campus, and we're still continuously developing it. We still continuously model additional models and link them to this campus model. And we are developing our systems as well. So we've looked at the common data environment and how to transfer data from project data to the asset information using our system. And in the future, we aim to integrate it with Planon and with the BMS. And for the future of the digital estates, we aim to integrate it with all the existing systems. And that relies on having accurate data from the beginning. So that's how we have looked at the Gemini principles in developing our digital estates and digital campus of Coventry University. And also we have to realize that the system is only as good as the user. We as users make it work. And we continuously develop it. We've got a simulation center, and the data that we have, we also give it to students to support them in the construction management courses, master students, and so on. And in summary, we aim to have better information management. We have we've been providing those case studies to the CDBB. We are members of the Digital Twin Hub, and we hope to publish more of our work in this area. Thank you very much.
Hadeel, you did a super job.
Thank you.
Fantastic. And actually, some of the comments from the delegates, a mammoth task you took on board there. You know, really fantastic presentation, real demonstration of practical efforts. No wonder you've won all these awards for the efforts you've made. I only wish TU Dublin Estates were listening to this presentation, only because we can all learn from each other how other higher education institutes are managing it. As you may know, we're building our own campus in Grange Gorman at the moment. So do we have any, so really super presentation, comments I have written down here. I mean, how large is the team that you have in Coventry?
So, well, we've got about 200 people in the estates department, and but if you talk about just the digital services team, we've got a team of 9 people, including myself as a BIM manager, an information manager, 2 systems administrator, and 3 CAD and BIM technicians who do the modeling work. But we work with our operation maintenance team and we work also with the development team. And that link between the project managers and the development team and the operation and maintenance manager has been essential. Just developing those communication. We started actually in 2017. Our digital service team did not exist before, but since we started, one of the main things is developing communication, cross communication between the departments, and I think that really helped us to digitize our estates, develop all of those processes that you've seen.
Yeah, and presumably at some point in time you've had to persuade the people to have the budgets.
Yes,
to take on people, to take on talent, to buy technology, and all the retrospective work you've had to do on the existing facilities. So I saw the university senior executive must really understand the importance of digital twins.
Yes, so as I first mentioned, we did not call them digital twins at the beginning. We talked to them about the importance of digitizing the estates. So that's how we started, because and I think we've been really lucky to have really good leadership team with a vision to go digital, to adopt those innovative processes, to ensure that all of our processes are aligned with the new industry standards, are following the latest technologies, and that's I guess how we started. And as you said, absolutely, we still have a lot of challenges of budgets, especially now when we reach the stage where we would like to start with integration, but some of the budgets are on hold now due to the current situation. And it's absolutely fine. Some projects will take more time, some will be delayed, but at least we started the journey and we're on track.
Other comments, Dan O'Gorman says excellent integration. Paul Bammer says great presentation, Hadeel. When do you get to sleep?
Well, that's a funny one, actually. I sleep. I think it's also part of it. You have to manage your time and ensure that the team also are not under a lot of pressure, and just really distribute the tasks between the team in a way that.
I was going to ask about the students, but you covered it at the end. You know that, like for example, next week we have a digital orientation. You know, with our first years, we can't bring them in to the building due to restrictions. So
we actually have
in the future having all this digital information that we can bring them through virtual tours through the buildings.
Yes, we have a simulation center, and we provide them with the data for the digital campus and models. And we also had 4 intern students over the past couple of years who did a lot of modeling for us. So we used the internship scheme with the School of Built Environment to recruit students who helped us to create models retrospectively, and then wrote reports as part of their dissertations or coursework. So that collaboration also with the academics really helped us to achieve this.
So hello to you all, and thanks for the opportunity to present today. This is a joint presentation with Anand Mecheri from Invicara, but a quick introduction from my side. You know, I look after the innovation direction and strategy, I suppose, for the Kingspan Group. Kingspan are a major supplier of lots of different types of material into the building construction industry, and as a consequence, this is something that's of interest to us. So I'll just hand you over to Anand for a moment.
Thanks, Mike. Hello, everyone. I'm Anand Mecheri. I'm the founder and CEO of Invicara. Invicara is a platform for developing digital twin solutions. And I'm going to talk more about it. Why do we call it a platform, and why is it? Why would I call it digital twin solutions as part of the IKON building presentation today with Mike? A quick background to myself: I've been in the building industry for close to 30 years. Built technology companies around smart building and innovation within the smart building space, and I look forward to sharing today. Thank you.
Okay, so just to put in context for what we're talking about today, the Kingspan Group has a number of strategies, around the business. But as it relates to the conversation that we're talking about today, there are kind of 3 intertwined pieces. One is around innovation and the next generation of products and materials and and where that will take us to in the future. Tied up in that is a very clear realization around our digitalization work, and that's a journey that we're on for a couple of years, and there's a long way to go in that. And the third piece of it is our Planet Passionate program, which is what we announced last year in relation to how we will deal with fundamental issues like climate change and the construction contribution, if you like, to that, and moving from a completely linear product set to a more circular product set and contributing to the circular economy. So they're the three intertwined pieces. A little bit about our innovation center, which we call IKON. We had it built, and it was actually designed by an architect called Niall Smith and built by a CGDM in Newry, from Newry. And we opened it last September. We kind of were just getting it up and running and started when we had to close it down again for a period due to the COVID-19, but that's how life is. At a summary level, it's the place where the difficult questions that are challenging our industry will get asked and hopefully answered. There's lots of themes, but the critical predominating ones at the moment are how we move to a zero carbon material set. How do we make sure that from a construction point of view, we move to a zero waste, both in our factories, which we're well advanced on, and outside in terms of sites and the material that we supply. And then on the digitalization side, the creation and use of digital twins, and we've seen and heard some fantastic examples in the last number of presentations. The use of data analytics, and where and what will be and how will augmented and virtual reality be used in terms of connecting products and data with user experiences. We set out a vision for the building to be a truly net zero carbon building that is digitally enhanced. And a lot of the issues that Hadeel mentioned in the previous presentation, even though this is a new building, were right there, if you like, all the way along on the journey. Particularly around data, structures, drawings, and probably within, you know, the construction industry, this is still all at a very, very early stage. And you know, there was lots of challenges to get the building, not so much on the physical side, but on the digital side, to get it to where we wanted it to be. We achieved the net zero carbon building by a number of factors, including reusing, for example, all the raw materials that was taken out of the ground. That was all reused in various pieces. We have installed, again, using a lot of the Kingspan product set, all the rainwater that falls on the site is fully harvested and reused. The energy comes from the heating and so on from a set of air pumps. We've installed a lot of solar PV, again based on solutions that we have and offer, which have contribute about 35% of the total energy that's used in the building. There's associated, let's say, electric car charge points and a car park, again, powered by solar. And all over the building, there's low energy lighting everywhere. And all of those things combined has led us, I suppose, to be awarded the LEED Gold standard from the US Green Building Council. You know, which for a building in a rural location with none of the points that you can get for being in an urban location, I think is quite a decent achievement. Inside the building, there are kind of 4 fundamental areas that we are working on and using the building for. The first is as a prototype lab on the product side for next generation insulation. Today we sell insulation for lots of applications across the entire spectrum. And there's lots of work from an R&D point of view we're doing in that space. Likewise, on the mechanical side, the mechanical product development piece, lots of stuff in terms of chemistry and state-of-the-art analytical capability. And as it relates to the discussion today, a digital lab and a digital team for the digital transformation of the business. On the digital side, we set out a vision, to have a digitally enhanced building, and working with Anand and his team at Invicara as they develop their platform, using lots of data with lots of BIM objects and BIM models and lots of documentation. We set about creating the asset twin, which is the fundamental building block, I suppose. Obviously, during the design and subsequently during the building construction phase of the building, the building management system was put in place. Lots of IoT sensors from lots of different places to track lots of things, again, that you'll see in the demonstration of Anand, that has allowed us create this operations twin. Now, our objective is really that we can, over the coming period with Invicara, to apply machine learning concepts to effectively optimize the running of the building and ultimately move it, hopefully, towards a self-managed building that can effectively take care of itself. And there'll be other, let's say, research activities that will go on. So there'll be research, if you like, and development in the building, and there'll be research and development on the building. On the right-hand side of that screen is our view of the digital twin, I suppose, stages or levels together with Invicara. We heard from the previous speaker the huge amount of detail that was required to make that project happen. And you have to have a strategy, and you have to have outcomes that are defined and well-structured information requirements. And honestly, at that point, because of the, let's say, the difference in data and structures and all that stuff that, again, Hadeel spoke about, it's quite easy to be almost turned off at that stage. Then you get your project twin, you get together to create the asset twin, the graphics, the data, the documents, as I mentioned on the left of that presentation. Then we integrate the asset twin with the building management system, the maintenance system, all the IoT, and that's effectively where we've taken the IKON building to today. We are going to work again with the partners that we have chosen, the team that's in place, to how we create that platform for continuous improvement around optimization of wellness, carbon, and so on, using machine learning as the pivot. And that project will go on over the next couple of years. This is just a screenshot, of the building with various sensor data on the left, and on the right-hand side here, you can see a particular graphic of a particular temperature, and then how that's transposed on the model on the right. Again, you'll get a lot more information about how this is actually working from Anand in a couple of moments. So as we look to the future and this living lab, and again, you can see some pictures and so on the right-hand side, and of what it looks like and how it is. We see a number of steps and opportunities and challenges, some of which we are almost there with, and some of which with the partner teams that we have in place will take some time. But using the digital twin to be able to manage this so-called golden thread of information. So what we want to be able to demonstrate, not only us, but I think the construction industry will be forced in terms of building to be able to confirm that all of the material that's used in the building is fit for purpose, has passed all the regulatory requirements, and has all of the data and characteristics that are needed. And all of that data, validating that, can be maintained and managed in the twin. And again, I think that's really powerful, particularly as we move forward in terms of how you can be assured that the product that you have used has all the relevant approvals and qualifications and so on. And obviously that's very important for us as a major supplier into the construction industry, because of the the need to be able to demonstrate that. Using the IoT data to measure the envelope performance. I mean, our overall strategy is really about completing the building envelope. So anything that's needed, from lighting to membrane to insulation to steel to whatever, except glass, Kingspan supplies. So we want to, and we obviously talk about what, based on testing and based on our R&D work, what the product can perform like. So we're using that IoT data at IKON to measure that envelope performance and check if there are any performance gaps, because that can feed back, obviously back into design and also back into product design, building design and product design. I mentioned earlier that, from a circularity point of view, from a Planet Passionate program perspective, the use of energy and the amount of energy that buildings use and the contribution that buildings make to CO2 emissions is enormous. And it's a key challenge for our entire industry. So again, using all this technology practically to measure the energy performance of the building, and again, compare to that to the as designed energy model. So again, we're using something futuristic to look back, and again, if there is lessons to be learned or things to be improved, then that will happen. We have a specific project working around how we can integrate the sensor technology inside our steel-based insulated panels. There's obviously some technical challenges with that, and again, we have a team of people both inside and outside working on that technology. Because again, that will allow the building material to actually act as a coordinator of the data. And we have some ideas around using microsensors to convert walls and facades into living skins that will respond when touched. And if you think about the potential for that in terms of occupancy, in terms of footfall, in terms of who has been where and so on and so on, but allowing the walls and the facades to respond to that, I think the potential for the future in that area is enormous. Again, we're just getting started on that. And as I mentioned, we've a number of projects in place. Obviously partnering with the Invicara team. We have a number of other defined partners in each of these areas to progress these challenges over the coming period of time. So that takes me out, and I'm now going to hand over to Anand. I don't know, Alan, if you want to take any.
Yeah, thanks, Mike. Super presentation. So
yeah, and I think it gives us the opportunity both in terms of the performance of the product, how it performs in a building, in a real life situation, and allows us to take that data and feed it back to the next iteration. That's where I think the real, from being selfish from our point of view. But I think there's a bigger picture looking out into the world, which demonstrates, how buildings, both new, and I know Simon, I think, made the point around that there's lots of existing buildings. I mean, there's a tremendous opportunity to push forward with this approach in the future.
I mean, buildings are expensive entities to manage. So whether you're a health facility like Bruce has, or an education facility like Hadeel, or just a building owner of a commercial building, it makes such sense to retrospectively capture that envelope and see what business benefits you can get from it, which would include obviously energy performance, energy savings, and so on. That's the nature of your business. So really good. And I'm hoping, I know there was plans last year to go and visit IKON, so hopefully something that we can do in the future.
We have set up a virtual tour, and if you drop me a note, we can organize that where you can, and again, you'll see some of the technology we have used to do that virtual tour in small parts of Anand's demo in a couple of moments.
Yeah, very good. Thanks very much, Mike. And I'm sure there'll be 4 questions as we get at the end. So, Anand, good afternoon.
Afternoon. Thank you, Alan.
Thank you for your support, by the way, for the event as well. Much appreciated. Hand over to you.
Pleasure. Thank you, Mike. Thanks for setting the stage there. I think through the day, through the last hour and a half, what we have heard consistently, if anybody's didn't get the message, it's obvious that if someone's going down the digital twin path, they're not looking to procure a product, right? So you're not. It it is a journey. It is really a digital transformation journey. And it's a platform for continuous improvement. And that's the outlook with which anyone should venture into the digital twin space, whether it is a manufacturing company like Kingspan, or whether it's an airport or a healthcare facility, or a university, or a commercial or residential portfolio owner. In the end, the digital twin strategy will drive in various outcomes, and it is going to be a journey, which means the digital twin strategy needs to be implemented around solutions that are modular. We can't get to the endpoint on day one. We need to be able to adopt pieces of technology that make sense to us today and progressively develop it. It needs to be flexible. It needs to be customizable. And also you want it to be interactive, API first type of approach where system of systems can be created through interactions. But really why? I mean, it's really worthwhile to think about why is it so complex? Why can it not be a product? The answer is very simple. Then the answer is every organization which is thinking about a digital twin has a set of use cases that are unique to them. There may be some commonality, but in all cases, we have observed that use cases are unique in one form or the other. These use cases drive workflows, and the workflows are going to be quite different. In the case of UCSF, and in the case of the university, clearly there was a strategy to use rich BIM models inside a CMMS application to drive the workflows around maintenance. But the use cases can be beyond maintenance. It can be asset management, space management, well-being of occupants, energy management. It can be stakeholder engagement. It may be about simulations. It may be about city management or campus management. So the use cases are different. The workflows to achieve those use cases are different. The roles of people involved are going to be different. The data flows and the data sources are going to be different. In some case, you may have a rich BIM deliverable in all-in-one integrated tool chain. In other cases, we may have very many disparate design tools being used and combined in an environment which is not really data friendly. So the data sources are to be managed. You then have to be able to create data models that are representative of what you're trying to achieve, and then apply the right type of analytics and the right way to present that information. So there is quite a bit of complexity if you think about digital twin at scale. So it is not something which is out of the box. It can be, but then you're going to try and drive a square peg in a round hole when we try to apply it. So what Invikara did was we decided to create a platform rather than a product. Think of it as a kit of parts. And what I'm going to show you with IKON, what we did with Kingspan and Mike at IKON, is just a manifestation of that kit of parts. So it could be somebody else who wants a completely different outcome, a completely different set of use cases. It could be leveraging some common data sources, but maybe different. So in this respect, you can virtually start with a clean sheet of paper and define what the solution is going to look like. So in this case, coming to IKON, you can see that the system is integrated with a 3D model. It was built in Revit, and we'll show you that. There is an integration with the scan, in this case Matterport. So we can actually use some of the graphics, more realistic graphics as part of your twin solution. There are various applications that have been deployed to use the model to drive certain workflows, an application for managing assets. So assets can be something that is derived from a model, or probably a list of equipment that was not in the model, but just from an Excel sheet. You still have to manage that information. Spaces, there was a lot of focus on spaces in the previous conversation. There's a lot of documents relating to the assets and spaces and others. There's an application to integrate with the building management and IoT systems. So we built a gateway, a smart building gateway, and integrated with the digital twin, which allows us to connect with any building management system, as long as we follow certain standards around protocols and such other. So in the end, the digital twin at IKON is able to address various use cases ranging from building management, whether it's maintenance workflows or operation workflows, well-being, energy management. And in the end, it's also going to be highly powerful in being able to support all the research work that Kingspan has already started, including the ability to understand the thermal performance of the envelope vis-a-vis changing conditions around the weather, occupancy, and so on and so forth. So giving you a quick spin through IKON. So you can see here, this dashboard provides us the high-level average value of the temperature, humidity, CO2 levels, and the particulate matter in the building. It gives us the aggregation of the energy consumption. So we can look at the, we see here there is some sort of an alert on the temperature. So we can go in and look at a more detailed dashboard. And this dashboard provides us with a deeper look into what the temperature trend has been over the last 30 days. Of course, we're also able to see it in a shorter period of time. We can look at the humidity or the CO2 or any of the other parameters. So you can see here that the building manager observed that in 2 days, there was a high particulate matter that was the result of a process in the prototyping environment. So it provides a very quick way for us to get an overview on what the building is currently delivering. And if you get into some more detail around the temperature, while everything looked good at face value, we can also see when you go down to the detail, we do have a higher temperature in one of the areas. So you can see that, and another area, it is not ideal, but we have other spaces that are